All right, graphing velocity and distance and time graphs. Okay. It can be difficult to make sense of a table of numbers that shows distance and time. If you plot these numbers on a graph, you can see all the information at once. So sometimes for a lot of us, just looking at a table of numbers, looking at a bunch of numbers just doesn't make a whole lot of sense. We collect a bunch of data and it just it doesn't make any sense. And so plotting a graph can help us to see what the numbers are doing. Velocity graphs are called distance versus time graphs. Okay. And simply, if you think about the equation for velocity, velocity is equal to distance over time. That's all a time. That's all a velocity graph is. It's that equation. It's distance over time. If you're using displacement change in position instead of distance, you call them displacement time graphs. Okay, so you can use displacement as well. Sometimes we use the word position time graph as well. When you draw distance versus time graphs, first of all, time is plotted on the x-axis. Okay, this is the one on the horizontal axis. So that's the one that goes back and forth, right? So the time is always on the x-axis. Distance is always on the y-axis. That's the one that goes vertically or up and down. Okay. The line of best fit that joins the data points gives information about the velocity. Okay, so you'll see that there will be all these points of data on a graph, and the line of best fit is the one that joins the data points together. Okay, so as there is a line of best fit of some kind, let's say there's dots along a graph, that will show us what it's doing. Okay, here we go. Here's a line of best fit. Notice that the title provides, so this, when we're looking at a graph, there's certain things we're always looking for, okay? And this is what I want you to have on your graph. Notice that the title provides two pieces of information, first of all. It's a distance time graph for a lawnmower, okay? First, it identifies the object being studied, right? Which is the lawnmower, and it also identifies the variables that are being measured for the graph. Okay, in this case, distance and time. This way, whoever's looking at it can know immediately what two data points and what exactly we're looking at. Okay, so the two axes show the following pieces of information. They show the units for each variable. Okay, so right here, time is in seconds. Okay, this is very important. You could have this could be, it's a bunch of numbers. This could be minutes, this could be hours, this could be seconds, this could be days. Who knows? And so that's why you always have to put uh, what units are being measured there. Same thing over here with distance. We have meters, right? It could be kilometers. It could be miles, right? It could be feet. It really depends. Okay, and so that's why it's important that you put that down. Again, time is measured in seconds and is on the x-axis in this particular case, and distance is measured in meters and is on the y-axis. The x-axis shows what's called the independent variable. So hopefully this brings you back to a little bit, maybe some bells are ringing from grade 9, which is the one variable that is purposefully changed in an investigation. So sorry, the independent variable is the one variable that's purposefully changed in an investigation. Okay, the one that the investigator changes. Here, the independent variable is time. Okay, sometimes the independent variable is called the manipulated variable, since it's the factor that's changed by the researcher. Okay. The y-axis shows what's called the dependent variable. Okay, the dependent variable is the variable that is measured as it's changed in response to the dependent variable. Here, the dependent variable is the distance the lawnmower travels during each time interval. Okay, so a dependent variable is also called a responding variable because it changes in response to the independent variable. So this is going to be important to know the difference between independent variables and dependent variables. Okay, the slope of the line, right? The slope of the line is this right here. The slope of the line shows that the lawnmower is moving at a constant velocity. Okay, it's the same velocity the entire time. That's what that means. It's a constant velocity. Okay, so now we're going to talk about constant velocities and changing velocities. So the graph on the left shows a straight line. Okay, so this is the distance time graph for a hockey puck. Okay, it's a straight line that is indicating a constant velocity. Okay, the graph on the right, okay, a distance time graph for an ATV or your quad or whatever, side by side, is a jagged line or a curved line. We like to say, okay, and this indicates the velocity of the object is changing over time. So this it's the same the entire time, and this it's changing the entire time. Well, it's changing. Now, it's important to understand this simply because we are going to look at some different graphs. Pardon me. This one happens to be a velocity graph or a distance time graph, right? But we're going to look at ones that have to do with acceleration later, and you'll see that that curved lines and straight lines and stuff like that mean different things with those graphs. And so please, when you're looking at it, it's important to know, first of all, it's a distance time graph there. So it's distance over time, and what the line means depends on that. You can use a distance time graph to determine the velocity of an object. To do this, you calculate the steepness of a line in a distance time graph, and this is called the slope. Okay, so some of you have already may have heard this in your math class. If you haven't, it's called slope, and there's a calculation we use to find the slope of a line. So here's the slope formula. So slope is the steepness of a line on a distance time graph and represents the velocity of an object being studied. The steeper the line is, the faster the object is moving. Okay. So we can see this is a very steep line right here. Okay. It's fast and a steady speed. It's a constant speed, right? The red one, you have a steady speed. Okay. It's stationary, as in you can see here. Okay. I'll get that to stop. You can see that there is a distance. Okay. And if you take a look down there, that's the time. And so the time is changing. Okay. Time is changing here, but distance is not. Okay. So this object is stationary. It's stopped. And then it returns back down to the start. Okay, so again the velocity is constant till it stops. And then of course here this getting faster. This is a curved line. Okay, like this. This will be a curved line. It shows that there's changing velocity now, and that's getting faster. Now, if you're curving that way, what do you think it means? Yeah, that is slowing down. It's getting slower. Okay. Okay, the steepness of the line is called the slope. You can use the slope of a line to calculate exactly how fast an object is moving. So use these steps to find the slope. First, choose 2 points on the line. Doesn't matter what 2 points, and it has to be a straight line. Okay, can't be the curved line. Identify and record the coordinates of the 2 points. For example, mark the numbers on the x-axis and the y-axis for each point. Okay, and we'll go through more of this in a sec. Find out the rise. Okay, the rise is the distance the interval travels. Sorry, the distance. This is the distance interval between the 2 points. Okay, to calculate rise, find the difference between the 2 y-axis points. Okay, and I'll show you how to do that. Find out the run. This is the time interval between the 2 points. To calculate the run, find the distance between the two x-axis points. Okay, then to find the velocity, divide the result of step 2, the rise, by the result of step 3, the run. Okay, so you may notice too that this is just slope is equal to rise over run, okay? Which is the exact same as velocity is equal to distance over time, because what is our graph? It's a velocity graph, right? What is the rise? The rise is the y-axis, which is where the distance is. The run is the distance is the y-axis, and the time or the run is the x-axis, right? So here we go. Here's our example. So this is a distance time graph for two objects. Very simple. Okay. Step 1: choose 2 points. So the 2 points that we choose are 2 and 2 and 4 and 4. Okay. So here's 2. Okay. There's 2 and 2. And here's 4 and 4. Okay. So those are 2 points. And x always comes first. Okay. X always comes first when you're writing them down. And so this is the x-axis and the y-axis. The x-axis and the y-axis. Okay. Now, step 2, calculate the rise to find the difference between the two y values. So this y value, 4 minus 2, 4 minus 2 is 2 for the rise. Now, step 3, we're going to calculate the run, okay, by finding the difference between the two x values. So again, it is 4 minus 2. Okay, 4 minus 2 is 2. And so step 4 is to calculate the slope or the velocity of the line. So velocity is equal to rise, which was 2, over run, which was 2, and that equals 1 meter squared, or 1 meter per second. Okay, 1 meter per second. So that's how you calculate the slope of a line. Okay, what is the slope of the distance time graph for the car in the graph shown below? Okay, so this graph is I don't really like this at all. It's hard to see. Okay, but we will. What I'm going to get you to do is I'm going to get you to restart. What is the slope of the distance time graph for the car in the graph shown below? Okay, so you're going to do this. I'll have an explanation for you after. Okay. Okay, here is calculate the velocity of the go-kart by calculating the slope of the line, slope of the graph below. Okay, so this is a distance time graph for a go-kart. This is a much better graph to use. And so I want you to remember, choose 2 points, right? The x and the y axis, the x and the y. What you want to do to find 2 points is you want to find 2 points that intersect exactly, okay, on the line here, okay. So here's 2 points intersect here. Here's a point that intersects here. Here's a point that intersects here. So you can use any of those 3 that I just identified there.